Hello. Today we are going to start looking at solving polynomial inequalities with one variable by graphing. Tomorrow we'll look at solving them algebraically, but today we're going to look at graphing to get us a start so that you can understand what we're doing. Alright, so first off I ask you to do the bell work. This is the question that we looked at. Solve the following polynomial. You are familiar with solving polynomials. We've just finished that up. And these are a couple of ways that you all approach that, and I want to talk about that because that will help you as we are going into solving polynomial inequalities. First off, some of you chose the algebraic approach. You factored out the x and then factored. A couple of you did synthetic division, and you found that your solutions, your x-intercepts, your roots were 0, -5, and 3. Some of you graphed it. You put it into your TI calculators and found that your x-intercepts were -5, 0, and 3. And again, you can see that even though you all approached it differently, you still came up with the same solutions. Something else that I would like to point out, a couple of things that you all said. Some of you were struggling. You only had 2 solutions. You were trying to figure out how to find the third. And that was very good for me to notice because you were using some of your properties from before in knowing that since it had a degree 3, you could have 3 solutions. Alright, so we're going to start with inequalities. On your guided note, you have example 1. Example 1 says to solve x minus 2x squared minus 3x is less than 0. And that is less than. I know that the lighting's a little bad there. Alright, that is less than 0. Alright, so the first thing that you want to do with this is make sure that you have the right side of your equation, this right side, equal to 0. You will keep your inequality, but you want the only thing hanging out over there. 0's a loser, so we want him alone. So you want him over there all by himself. Once you've done that, then you're going to graph the left side in your calculator. So you'll go to y equals, and in y sub 1, you're going to put x cubed minus 2x squared minus 3x. So I'll give you just a second while you do that. Alright, now that you've done that, this is what your graph looks like. On this graph, you will notice from what we've done with polynomial equations, you can quickly see what your zeros are, and that's actually what you're going to do next, is find the zeros of the polynomial. So, what are your zeros? Very good. -1, 0, and 3. We identify that by finding our x-intercepts. Now that you've done that, then you want to focus on this inequality sign. The inequality sign is very important here. When we're looking for when is it equal, that's when those are the zeros. This one is when is it less than. So you want to look at your graph and see where is the graph less than 0. So here, this portion of the graph under the x-axis is going to be less than 0. So we actually have a section here and we have a section here. So the next thing that I like to do is to plot the zeros on a number line. That helps me figure out what my inequality notation, and sometimes you're asked for interval notation. Now notice on the number line I put open circles at my zeros. I used open circles because this is less than. If it were less than or equal to, I would close them in. All right, now, then what I want to do is to highlight where it's below. So from negative infinity to to negative 1 is below 0. And then also from 0 to 3 is below 0. So our solution is x is less than negative 1 and x is between 0 and 3. All right, let's look at one more example. Okay, for this one we're going to solve x squared minus 1 and x minus 4 squared greater than or equal to 0. So if you want to start out, we do have it equal to 0 on the right hand side, so we're going to graph the left hand side. When we do, this is what our graph looks like. Next, you're going to identify your zeros. These are nice zeros. Later on they won't all be. So we have negative 1, 1, and 4. 4 is what we call a double root because it kisses and runs. Look at the graph on the calculator and determine, now this one, it's greater than or equal to, so we want where is it going to be above the x-axis. So above the x-axis, if I plot my number line, and notice I have closed circles because that's a greater than or equal to. So closed circles. So it's greater than from negative infinity to negative 1. It's also greater than for this whole section here. Even here, this is equal to 0, and we can include that point because we're looking at equal to. So our sections will be x is less than negative 1, and also x is greater than 1, and we want to include that entire thing. Now what I would like for you to do is to work on this question with your partner.